So second part we'll be talking about a scalar product of a plane. So we have learned how to find the vector equation of the plane, and from vector equation of the plane we can derive a scalar product of the plane. Okay, what does scalar product of the plane consist of? So let's say this is my vector equation of my plane, which consists of a point and two directions. So d1 and say d2. Okay, what to form the scalar product of a plane, I will need a normal over here. Okay, and normal can be found by crossing your d1 and d2. Take note, the normal is always perpendicular to the plane. Okay, for a scalar product of a plane, it should look something like this. R dot n represent your normal. As usual, R will represent any point that lies on the line, which will give me alpha. Alpha is a constant over here. Okay, we have to learn how to find the normal first. Then from there, we're going to learn how to find the constant at the back of your scalar product of a plane. So for example, over here, we're going to use this plane equation. Plane equal to r equal to 1, 0, 2, the point that lies on the plane, plus lambda 1, 2, 1, the first direction, plus mu 3, 4, and 2. Lambda and mu are real number. Okay, so imagine I am given this vector equation of a plane. I need to form the scalar product of the plane. First step, I will always go and find the normal first. So the normal is equal to d1 cross with d2. Okay, essentially is equal to 1, 2, and 1 cross with 3, 4, and 2. So it really doesn't matter what kind of direction you have in your vector equation of a plane. By crossing them, so long they are direction that are parallel to the plane, I can cross them and I should derive the same normal as everyone else. So using this quick calculation, I should get 4 minus 4 for the I component, minus 2 minus 3 for the j component, and 4 minus 6. And this should derive as 0, 1, minus 2. Take note, for cross product, always remember to do a quick check using your GC by checking with the dot product. Okay, so a quick recollection, those who have followed my vector 1 equation, my vector 1 lecture should actually understand this. So quickly check by taking the cross product, dot with your 2 of your vector. Okay, you should get 0, and this will ensure that you know that you are in the correct track. Since vector product will always be something that is cross product or vector product, essentially will be something that a lot of students get careless mistakes from. So once I confirm my normal, I'm going to try to find the constant at the back of the equation. So my plane equation should look something like that. Pi, which represent plane, r that represent any point on the plane rather, 0, 1, minus 2, which is your normal. Okay, I need to go and determine the constant. Since r represent any point that lies on the plane, I can actually use 1, 0, 2, derive from the vector equation of my plane. Then from here, I dot with my normal. Okay, I will actually get minus 4. So my plane equation essentially will be r dot 0, 1, minus 2 equal to minus 4. Okay, this is a scalar product of the plane. Everyone will have the same normal. If not, will be a negative of normal that other people found. Okay, so from here, we can actually derive a fair bit of different things. I can quickly check if a point that lies on a plane, because once I take that point dot with my normal, it should get minus 4 at that point that lies on the plane. For example, I can quickly say that 0 minus 4, 0 lies on the plane. Also, 0, 0, 2 will also lies on the plane. Okay, if not, you can also see that you can actually have any values on the I component since the normal is 0. You can have 4, you should have minus 2 and 1. Okay, will also lies on the plane as well. Okay, so given the question given you two line equation, so find the scalar product of the plane that contain L1 and L2. So given that the plane contains two line equation, okay, you can quickly draw out. This is my L1 and this is my L2. You can quickly use the two direction of the line as your direction of your plane. So your plane should look something like that. R equal to, okay, you can use 3, 4, 3, okay, use 1, 2, 1, doesn't matter. So over here I'm going to use 1, 2, 1 plus lambda, 1, 1, 1 plus mu, 2, 3 minus 1. Okay, since the question already used lambda and mu, so let's try to avoid using lambda and mu again. Okay, we can use alpha and beta, so where alpha and beta are real number. So from here, I need to go and quickly determine my normal over here first. Normal will be equal to the two directions crossing each other. Okay, so quickly calculate, I'll get minus 1 minus 3 minus 1, minus 2, and the last row will be 3, minus 2. Okay, this will give me minus 4, 3, and 1. Okay, you can quickly use your dot product to check as well. Okay, once I get my normal, I'm going to find my constant at the back. So R, plane equation is R dot your normal. Okay, so I take the point that lies on the plane. I can use 1, 2, 1 or 3, 4, 2, doesn't matter. I should derive the same constant at the back as well. Okay, this will give me minus 4 plus 6 plus 1, which will give me 3. So my plane equation essentially is R dot minus 4, 3, and 1 equal to 3. Take note, your normal, your n represent a direction that's perpendicular to the plane. So likewise in your vector equation of a line, vector equation of a plane, if you can simplify your normal to the simplest form, please go ahead and do it. Okay, this will help you in your application when we actually further down in vector 3.